Hello everyone, and thank you very much for watching this video. I was asked by Peter to explain a little bit better the way overriding works for methods with exceptions, and that fourth rule, how I call it, for overriding, and that's precisely what I'm trying to do in this video. So let's start with a coding example, and then I will try to show you a visual to build together a visual on this. And with this, I hope I will clarify all the questions. This subject is a really important one, also for practical scenarios as well as for your OCP certification exam. In case you want to get that certification, you need to know very well the rules of overriding. So I'm glad that you have asked this question, because again, it's a really important subject. So I've already created here a project. I'm using Java 14, but that's not really important because this is something so fundamental that's actually working the same from the beginning of the language. And as you know, I'd like to remind you that we have two kinds of exceptions in Java. We can classify them in runtime exceptions and checked exceptions. The runtime exceptions are those kinds of exceptions for which the compiler doesn't check anything. So it doesn't check if you actually treat them at some point, which means that you can throw those exceptions and you can avoid treating them. And those kinds of exceptions can appear at runtime. That's why we actually call them runtime exceptions. It's because they can appear at runtime. While the other category, which we call checked exceptions, those are the exceptions that the compiler doesn't allow you to not treat them. That's why we call them checked exceptions, is because the compiler checks that they are treated before you can even compile the application. So that's why you can never have those kinds of exceptions at runtime. So you cannot compile, you cannot even build your application if you didn't take them into consideration and if you didn't treat them at some point. And I will start with the runtime exceptions, explaining you that in case of overriding, you don't actually have anything to do with the runtime exceptions, so they are not part of the rule that we discuss here. But I want to say that so that you are aware of this aspect, and I would like to start with this because it's very simple. And then we go to the rule where we discuss about the checked exceptions, which are actually the kinds of exceptions about which we discuss when we have this overriding subject. And let's create first a package here. I'll call it main. And inside the package, I will actually have two classes. I will call class A, and I will call the second class B. And of course, I will make sure that class B extends from A. So we have an inheritance here. And having an inheritance, of course, we can discuss about overriding. So you can now simply have a method here. So it's public void m. And then you have the second method, which overrides the one in class A. In class B, you have it here, and you see that my IntelliJ is smart enough to show me that this is an overriding. And of course, if you'd like to also make sure yourself, you can simply add this override annotation above the method, and if this compiles, now it really means we have an overriding. And we have an overriding because we do respect all the rules of overriding here. You see both methods are public, and you have the same, in this case, it being void, you need to have the same return type. And then we have the same identifier and the same parameters, and we don't have exceptions. So this is clearly, in this case, a simple and easy to observe overriding. But we now kind of discuss about the fourth rule of overriding. So I will leave out all the others, which represent the access mode, the return type, and of course the identifier and the parameters. And we only discuss about throwing exceptions here. And I'd like to show you for the beginning again that if you have a runtime exception, you can throw any kind of runtime exception and nothing happens. The overriding is not affected by runtime exceptions. So when you throw an exception like, say, null pointer exception, which by the way never throw null pointer exceptions in real life scenarios. This is kind of exception that you don't need to treat or throw. It's a kind of exception that you need to make sure it doesn't appear because of the way you write the code. So the null pointer exception is basically happening when you refer to a method or to an attribute from an instance that's null. Of course, I should have said to a behavior or an attribute from an instance that's null. In my case here is just to prove my example, because you see null pointer exception indeed is a runtime exception, and you can see that I can override and I can throw null pointer exception here, and it's still a good overriding even though I have no exception thrown here, because again, runtime exceptions are not relevant for overriding, so you can have any kind of runtime exceptions thrown out of the method. By the way, in Java you don't actually need to throw runtime exceptions. You can do that. The only reason for why I've shown you these throws here is to clarify that the syntax is possible, but in a real world scenario you can actually throw a runtime exception and you don't necessarily need to throw it out from the method just because they are runtime exceptions, so they are not checked by the compiler. But one of the important things to remember is that the syntax is correct, so you can actually write throw and runtime exception or any kind of runtime exception here. You can enumerate more if you'd like, even though they are runtime exceptions. And the reason you need to know this syntax is correct is of course still for the case in which you attend the OCP exam, and of course for the OCP exam you need to know a lot of syntaxes that are not necessarily really important or found really often in real world scenarios, but you will be tested for them, and that's why you need to know them. So do remember that you can actually write throws also for a runtime exception, even though that's not needed, and in a real world scenario you won't do that. And again, from this, remember that in case of overriding, this is not important. You can throw as many runtimes exceptions here as you'd like. You can throw any kind of runtimes exceptions here. It doesn't matter at all. So you can write null pointer exception here, and then in B you can override it, and it's still a correct overriding. You see I have no compilation error if I throw runtime exception here. So when we discuss runtime exceptions with overriding, the subject and the only thing I say you'd like to remember is that they don't influence the overriding. However, the thing doesn't stay the same when we discuss checked exceptions. So for checked exceptions, we have a really important rule when using them together with overriding methods. That means when you throw an exception, when you specify that a method throws a kind of exception, and that exception is a checked exception, you have to make sure that a method that overrides another one doesn't throw more exceptions, so a larger spectrum of exceptions than the one it overrides. So say that my method M in class A doesn't throw any kind of exception, like in this case here, you see, I don't throw any kind of exception here. If I'd like to go to B and I'd like to throw any exception that's a checked exception, and again remember we discuss here now only about checked exceptions because we have clarified that with runtime exceptions we have no problem, but with checked exceptions we do have problems. And say I take any kind I'd like, custom or from the JDK kind of exception, if that's a checked exception, it won't compile in my case if I try to throw it from here, just because the method in A doesn't throw that exception. So say I want to throw file not found exception, and this is an exception that's in Java IO package, but that's not important. The important is that this is a checked exception. It extends directly IO exception, and further it extends exceptions. So you see it's not below runtime exception in the inheritance tree, and that makes it a checked exception. That means that the compiler tests this exception. You see clearly here that in case of a checked exception, my overriding here doesn't work anymore. This wasn't the case when I use null pointer exception, isn't it? See, with null pointer exception everything works fine. you have no compilation problem because it's a runtime exception. But when we discuss checked exceptions, you cannot throw from a method that's overriding another method more exceptions than the method it overrides, which means that method M in class B cannot throw more exceptions, more checked exceptions, than method M in class A. And because in our case here method M in class A doesn't throw any exception, of course that means that the only syntax that would compile in my case is to throw no checked exception from this method as well, because anything you add here would mean more than nothing, more than no exception thrown. The other way around, however, it works. So the idea is that method that's overriding cannot throw more exceptions, but it can throw less exceptions. So if I move the throws clause in method M of class A, then of course that simply means method M throws that checked exception. But you can actually have method B throwing no exception, for example, in this case. Or you can make this method throw file not found exception if you'd like now, because that wouldn't mean that it throws more exceptions than the method it overrides. It now throws the same exceptions. And moreover, you can throw any exception that's a child of this exception, because that would mean it's more particular. So I don't have in mind now an exception that's a child of file not found exception, but we have just seen that file not found exception extends from IO exception. And I'd like to use this example because I know it's an exemplar really often encountered in the OCP exam, and that would be helpful for you in case you'd like to attend that exam. So let me show you this. Instead of throwing from A file not found exception, I will throw IO exception. And I will throw IO exception, and what you will observe is that now the method M in class B can either throw nothing, because that means less exceptions than IO exception, or you can throw IO exception because that's the maximum you can go. That means you now throw the same exceptions as the method you override, but you can at the same time decide to throw file not found exception, and this works as well because file not found exception extends from IO exception. So being that it extends, we know that inheritance is also called the is a relationship, which means that file not found exception is a IO exception. So it's more particular than IO exception, which means that polymorphism applies here, which means that you can also throw file not found exception even though it's a different exception, because it's at the same time an IO exception from the inheritance logic. And the last thing we need to discuss is that, of course, you know that you can throw multiple exceptions here by separating them with a comma. Well, of course, I would not be able now to throw some other checked exception here. That would mean I throw more exceptions than the method that I override, isn't it? So that means that if I have here another kind of checked exception, I'm not sure now which checked exception should I try. Let me just create one of mine, because that way we also covered the case in which exception. Of course, we use our own exceptions, and you'll see it's the same thing. So you see I have created this E, which is an exception, and it's not a runtime exception, it's a checked exception because it inherits directly from the class exception. Well, of course, I cannot just add E here, because it will again say that I try to throw more exceptions than the method I override. But you can have the situation in which, again, the method above, the method in the class above, throws both these exceptions, and then of course you can decide in class B to either throw no exceptions, or you can decide to throw only E in this case, because that means less exceptions still. You can decide to only throw, for example, a file not found exception, because it's still less, because the above method throws IO exception, but file not found exception is a particular case of IO exception. So that means we are still in the case in which you throw less exceptions. You can decide to throw file not found exception ND, for example, because we are still in the case in which we throw less exceptions. We throw file not found, which is an IO exception, and we throw E, which is again accordingly to what we have in the above class. Or you can decide to throw IO exception and E, which is the maximum you can go. You cannot throw more than this. And I will end, of course, with telling you that here you again, I know I've repeated it multiple times, but I want to make sure I'm clear with that. You can add here and there any kinds of runtime exceptions that they will not affect. So I can decide to just add a comma there, and along with these exceptions just add also null pointer exception, because that's a runtime exception and that doesn't affect the overriding at all. And now let me also draw a visual to make sure that everything was clear and that I've explained it as good as I could. So I will simply try to design this class as a rectangle, and I have a separate class down below, and you know that they are extending one is extending the other like this. Okay. Okay, and this is class A. And this is class B. From our coding example, of course, they both declare method M. Which I write here public void M. And what you need to know again is that when you override, the rule regarding exceptions for overriding is that you cannot have here, so I will say the method that overrides, which is this one, cannot throw more exceptions. Okay, so I hope this is now clear. So here you cannot throw more exceptions than in class A, than in the class that you extend. So more exceptions than this method you have here, which means that if, and we discuss about checked exceptions, okay, because the runtime exceptions, again, they don't affect the overriding. So if you here have nothing, here you can also only have no checked exception. If you here have throws exception, which means in Java any kind of exception, because exception is the top class of the exceptions, is the mother of all the exceptions, then you can have here absolutely any exception. You can say here throws exception, which is the same, or you can say here throws IO exception, and it still works because IO exception is an exception. Or you can say throws IO exception and any other exception E, that's a checked exception, and so on and so forth. So they will all work because you have here less exceptions than here. And by less, I mean not necessarily in number, because exception here, for example, by polymorphism, it covers all the exceptions. Then you can, for example, here enumerate more, and if they are all under exception, and they are, because in case of Java, exception is the mother class of all the exceptions, then it will work. Or for example, you have here IO exception, and then that will not work anymore, isn't it? Because E is not under IO exception. So I have to take it out, and this will compile now because both of them have the same. But I can also say something like file not found exception. And this will work because file not found exception is extending from IO exception. So it's is more particular than IO exception. So that means it's less exceptions than in the method it's overriding. So that's basically how exceptions work in terms of overriding methods, and this is what you need to know and what you need to recognize for your OCP exam, but also something that you pretty often work with in and may encounter in real world scenarios. Why not? And the thing that you need to remember is, in a short sentence about this rule, definition would be: the method that's overriding cannot throw more exceptions, more checked exceptions, than the method it overrides. And by more I mean the exceptions covered in general, which not necessarily mean the number of exceptions, but the spectrum of exceptions that's thrown from the method it overrides. And hopefully with these examples I was more clear and you understood. Let me know. Your feedback is important. And thank you very much again for your question, and have a great time for study.